Oh, there you are, Frank. Since when can the office boy keep banker's hours?
What do you mean, banker's hours? I was the first one in this morning.
A likely story. Nothing's doing around here. My inkwell hasn't been filled. All these pencils need sharpening.
I had more important things to do first.
Such as?
Dusting Mr. Goldthwaite's desk, sharpening his pencils, and a few other items, Toots.
Toots?
Yes.
Such impudence. You'd think you were somebody around here.
Well, maybe I will be someday, Toots. Maybe I will be.
You don't make me laugh.
Well, one of these days, Mr. Goldthwaite will see who keeps things running around here, and he'll make me vice president.
Yeah, vice president in charge of brooms and dusters. Now get to work. And wise up, Frank. You're not a character in any Horatio Alger book.
Whoever that is. But when I'm in Dun & Bradstreet's book, look me up sometime, and maybe I'll give you a job as my private secretary.
Speaking of the Horatio Alger books, remember them? All about poor boys who rose through honesty and hard work and just a wee smidge of luck to fame and fortune. Why bring them up here? Well, maybe many boys don't read the Alger books today, but our science reporter Emerson Markham was saying a few minutes ago that if Horatio Alger had written the life story of the scientist we'll be meeting on this excursion in science, he could have made it as improbable as any of his novels. Yet everything in the story could have been true. Check, Emerson?
Check, Bob. How do you do, everyone? What I said still goes, Mr. Stone, for from a very humble beginning, Michael Faraday became probably the greatest experimental scientist the world has ever known.
Oh, Michael Faraday's the man of the hour. The quarter hour.
Yes, he is, thanks to Neil B. Reynolds, who told me his story. Michael Faraday was born in September of 1791, a few miles south of London. His father was a blacksmith, and eventually the family moved to the metropolis itself.
And they were poor people?
Yes, Bob. And if you've read Dickens, you know what the lot of the poor was like in the London of the early 19th century. But somehow James Faraday managed to give his son Michael several years of schooling. And when the boy was about 13, he was apprenticed to a bookseller and a bookbinder.
But Emerson, that doesn't seem like a fitting background for someone who's to be a great experimental scientist. How'd he get that way?
Well, as a start, in his new job with the bookseller, he not only handled books, he read them. He read all kinds of books, and among them were books on science. They led him to attend some of the public lectures by the great Sir Humphrey Davy, director of the laboratory of the Royal Institution.
Sounds like a good break for a poor boy who made good.
Well, he didn't let it go at just attending those lectures, Bob. Faraday took very careful notes of Davy's lectures, wrote them up, bound them neatly, and sent them to Davy. And Sir Humphrey was so impressed that he hired young Faraday as his assistant. That was in the spring of 1813, when Faraday was 21 years old.
Up one rung on his ladder of success. I suppose the bright young man took advantage of that chance, too.
He did indeed. Or maybe Davy took advantage of it. Anyway, when Davy went on a scientific junket over half the continent of Europe, he took Michael with him, half as a secretary, half as a servant. It was a great experience for a young man who had scarcely been a day's journey from London. And in the year and a half abroad, he met many notable scientists.
They do say travel broadens one, but Emerson, where did his experimenting come in?
On his return, Bob, Faraday was soon experimenting on his own account at the Royal Institution, and lecturing, too. In 1825, Davy's health began to fail, and to Michael Faraday, then only 33 years old, was given the position of director of the laboratory. A little later, he was made professor of chemistry, and these two positions he held until his death in August of 1867.
That's some success story, Emerson. Imagine becoming the head of one of the world's great scientific institutions without ever having had a college education.
Without ever having had the equivalent of a high school education, Bob. But Faraday was an amazing man.
Could be, but you haven't told us anything he did except about his work at the Royal Institution.
Then by all means, let's look at a few of the things he did. Michael Faraday is probably best known for his discovery of electric induction. That, you will remember, was discovered independently at almost the same time by Joseph Henry.
As a matter of fact, I didn't remember, but go on.
Well, that discovery alone in 1831 was enough to make a man immortal, and it lies at the root of practically all the electric machinery we use today.
Electric induction, way back in 1831. Yes, it would make you sit up and take notice. From what you said, I take it there was even more.
Yes, indeed. Faraday laid the foundations for the science of electrochemistry, working out the facts of ionization and electrolysis, and much of what we know about electric batteries. He studied gases and showed how some of them, like chlorine, could be liquefied. Working with magnets and polarized light, he demonstrated that in some materials the plane of polarization is shifted by a magnetic field.
Gosh, he sounds more like a modern than someone who might have been a character in Dickens.
And to show how close his work came to the present, he tried but just failed to discover what we now call the Zeeman Effect, a shift in the wavelength of spectrum lines in a magnetic field that has played a large part in the development of modern atomic theory.
He had his fingers in quite a few pies, didn't he?
He did indeed, Bob. It's just hopeless even to try to enumerate the fields in which Faraday worked, for his whole life was devoted to experiments, careful, methodical, yet brilliant. Everything he did was recorded.
By himself?
Yes. His notebooks are models of clear description. Every paragraph is numbered, and the numbers are cross-referenced, so that the relation of each experiment to every earlier one is made clear.
Very workmanlike. You'd almost expect such a busy person to jot his thoughts down, if he did it all, on a stray envelope or something.
And the man Faraday is as interesting as his work, Bob. He was a friendly, cheerful, kindly person. His married life was very happy. He enjoyed sitting with his wife and admiring the sunset. For 54 years he lectured and experimented at the Royal Institution, and at the end, though burdened with a failing memory, he was as enthusiastic as when he had entered its doors as a youth of 21.
But he must have been pretty well known. Did his success affect him in any way?
No. He was modest, too. He refused the presidency of the Royal Society at one time. Had he played politics, he might have become Sir Michael Faraday, as his predecessor had become Sir Humphrey Davy. Instead, in one of his rare bursts of irritation, he made a Prime Minister of England, Lord Melbourne, apologize for an ill-chosen remark. Faraday was a little man, with a mane of white hair, a twinkle in his eye, a word of encouragement and advice for all young men in science. The world had been good to him. It had given him the opportunity to do what he wanted to do most and could do best. And so, as he said to his friend, John Tyndall, he was content to remain plain Michael Faraday to the end.
But we'll remember, thanks to you and to Neil B. Reynolds, that his accomplishments were far from plain. Ladies and gentlemen, if you would like a copy of a thumbnail sketch of Michael Faraday by Neil B. Reynolds to add to your scientific library, all you have to do to get one is address your request to Excursions in Science in care of the station to which you are now listening, asking for thumbnail sketch of a great scientist, number 144, entitled Plain Michael Faraday. That's Plain Michael Faraday, thumbnail sketch of a great scientist, number 144. We'll see the one is put in the mail for you free of charge. And now, once again, according to our custom, it's time for our question and answer period. The questions have been submitted as usual by you listeners. The answers are accurate and up to the minute, for they are based on information supplied by staff members of the General Electric Research Laboratory or of other equally reliable institutions. Well, Emerson, let's up and away with this communication from the top of the pile. It comes from a lady who asks, what is the difference between red and pink salmon?
I asked John T. Nichols, curator of recent fishes at the American Museum of Natural History, about that, Bob. He says that the names red and pink salmon may be used differently in different localities, and that he is familiar with them only on the Pacific coast, where there are two different species of salmon, more officially known as the blueback, which is the red, and the humpback, which is the pink.
Did he say which one is better for the table?
Well, he did say that the red, which is the blueback salmon, is a small species which runs into fresh water earlier in the season, that is, several months before deterioration which accompanies the spawning season. For this reason, it's one of the most excellent salmon for the table. Incidentally, Mr. Nichols pointed out an interesting fact about the meat of this red salmon. He says it has a deeper colored, redder meat than any other salmon that he has known.
Then has the humpback or pink salmon rather light-colored meat?
Yes. It enters fresh water later in the season, and therefore is rather second-rate on the whole. However, it is taken in considerable quantity while still in salt water in Puget Sound.
Then I suppose in that region it would be considered an esteemed fish for the table.
That's right. And it is there that the name pink salmon is current for it.
And now a question about carbon from another listener. He assumes that carbon is of organic origin and wonders why, therefore, it appears in the form of a diamond, where, as he puts it, life could scarcely seem to ever have existed.
Oh, but carbon does come from sources which aren't organic, Bob. For example, graphite and diamonds have been found in meteorites, and graphite is found in certain rocks.
And diamonds are composed of carbon, Emerson?
Yes, they're composed of pure carbon in a crystallized state. The whitest and clearest of these stones are used for jewelry.
Are the white diamonds of a better quality than those of another color, Emerson?
Well, diamonds, as well as being white, can, of course, be yellow, green, red, violet, blue, or black. However, those most sought after to be used as jewels are those that are the most clear, the most colorless, and the most flawless.
Now, next we have this inquiry. In which season of the year is the sun nearer to the earth, summer or winter?
Contrary to what you might think, perhaps, the sun is nearest to the earth during our coldest weather. It is during the month of January that the sun is 3 million miles nearer to the earth than it is at any other time.
But, Emerson, why don't we have warmer weather then if the sun is nearer to the Earth?
Well, the reason for this is simply that in the wintertime the sun is low, and a beam of light, for instance a yard square, would spread over several square yards of the Earth's surface. Now in June, the sun is directly over our heads, and the yard square beam would cover only a square yard of ground.
Then you mean that a beam of sunlight is more concentrated in June than it is in January?
That's right. And that is why we have summer beginning in June in the northern hemisphere when the sun is high, and winter in December when the sun is low. It's just the other way around, of course, in the southern hemisphere.
Well, here's an interesting one, Emerson. It's from a lady who writes that due to the fact that she is a vegetarian, she does not use leather. She wears rubber-soled shoes or sneakers, but has been told that their use is not to be encouraged because they intercept whatever current flows between the earth and the body. Now she'd like to find a cloth shoe that is sold to the non-animal conductor of electricity. She asks if plastic is a conductor of electricity.
Well, in answer to her question, whether plastics are conductors of electricity, let me say that they vary. Most of them are insulators, some better than others. This can be controlled to a certain extent in manufacturing. Now, about the current flowing between the earth and the body, there is no evidence to that effect. A disadvantage of rubber-soled shoes is, of course, that they do not let moisture out and ventilation is needed for the feet. With plastics, you would probably have the same effect.
Okay. Next is this one from a listener who informs us he has purchased a 16mm movie projector. He'd like us to tell him how to make a good screen that'll show the film the best. Will you give our friend this information, Emerson?
Very glad to, Bob. This would be one way to do it. First, mount a piece of muslin or ordinary sheeting upon a wooden frame or other suitable support of the desired size. Then apply a coating of shellac to the material.
The shellac might not be obtainable at the present time, though, Emerson.
Well, then, in that case, some other suitable sizing substance of the nature of a lacquer could be substituted satisfactorily. Now, after the screen is thoroughly dry, apply 2 or possibly 3 coats of flat white paint.
Any particular way of putting on the paint, to get the best results, I mean?
We'd suggest spraying the paint on the screen, but if that isn't possible, it may be applied with a brush. If our listener prefers to buy a screen instead, we suggest that he consult his local photographic supply dealer.
Next, listen to this one, Emerson. Could you tell me, the gentleman asks, whether or not it is true that a doctor who works with X-rays lives a shorter life than he would if he had never been near them?
There's no reason for the life of a physician working with X-rays to be shortened if he takes the necessary precautions. However, if he were exposed to the X-rays and continued to be over a period of time without taking adequate protective measures, there is certainly that danger.
When you say protective measures, you mean the wearing of protective equipment, such as gloves, apron, and so forth, don't you?
Yes, that's right. There are various types of protective equipment, depending, of course, upon the type of treatment used. For example, there are leather gloves and aprons which are leaded, and there are also, in some cases, leaded walls of the rooms in which the treatment is administered, plus lead glass screens. You see, there are different types of X-rays, such as fluoroscopic and radiographic.
Next, we have this one from a man who asks us how to remove white stains from a red brick porch. He tells us these stains are the result of salt having been applied to melt ice. He also says he's used vinegar to remove the stains, but is unsuccessful. Could you recommend anything to him, Emerson?
There are patented proprietary cleaners available, which usually are emulsions of linseed oil, gum tragacanth, rosin oil, and other substances, together with hydrochloric acid. The only suggestion that we can make is the use of diluted hydrochloric acid.
How should he apply it, Emerson?
The best way would probably be to moisten sawdust with a 10% solution of the hydrochloric acid and then apply this moistened sawdust to the spots.
Now, how about this one from a friend in British Columbia, Canada, Prince Rupert to be exact. He asks, what is the propelling mechanism of germs? It seems he read somewhere that germs can travel from one side of a room to the opposite side at the speed of 300 miles an hour. Is this true?
Well, I'm afraid not, Bob. Germs are like dust, borne through the air. They are wafted around in the atmosphere like fine dust particles, breathed and picked up in that manner. As far as we know, there is no particular speed at which they travel.
Well, it's time once again for me to say thank you, Emerson Markham, and goodbye, everyone, until our next excursion in science.